So tonight, Saturn and Jupiter, they would appear very close to each other. And last time when they were seen so close was 400 years back. So this is going to be once in a lifetime opportunity to view this event. And I welcome you all to join me in this talk where we are going to discuss about what the Great Conjunction is and how it is caused and why today's Great Conjunction is the special event. So let me share my screen with you. So I am going to cover the following topics which are related to the conjunction. We'll start with major celestial events that happened or happening in December 2020. And to understand what conjunction is, we also need to understand a little bit about our solar system and planetary motions. Then we'll go into details of conjunction and great conjunction and what caused the great conjunction, what is so unique about this year's great conjunction, and how to view the conjunctions, and what are the conjunctions that are set to happen in future. So this month, there were several new things that were happening in the sky, starting with this gem meteorite shower that happened in I'm sorry, that happened around the second week of December. And then there was a total solar eclipse in December 14. This solar eclipse was not seen from Indian subcontinent, but it was viewed from Latin America and also from a place like Argentina and Chile. And today is the great conjunction of Jupiter and Saturn. And December 21st also happens to be um, the solstice day, the day in the northern hemisphere where the day in the northern hemisphere when you have a shortest uh, daytime and the longest night. And later on, there's another shower, meteor shower that is coming up. And December 30th, a day just before the year ends, would be the full moon of last full moon of this year. And it's also referred as cold moon because during this time of the year, we have uh, all cold in the northern hemisphere. So this is the view of our solar system. We have sun in the center of solar system, and there are 8 planets which are in different orbits. So there are 4 inner planets starting with Mercury, Venus, Earth, and Mars, which are like rocky planet. We call them rocky because their surface is hard. You can go and step on that, or you can walk on that, or you can land, and you can build houses, right? They are made up of solid rocks. And then the outer planets, which are also called giant planets, are Jupiter, Saturn, Uranus, and Neptune. And all these 4 planets are made up of gases. They are gaseous planet, and their surface is not rocky. So if you have to go onto one of these planets, uh, you are not going to have a hard landing on those because there's no surface to land on. It's just the gas which becomes, the density of the gas which becomes higher and higher. So eventually, if there is a probe which goes onto one of these planets, at least Jupiter and Saturn, it would slowly sink into the planet. The next outermost 2 planets, Uranus and Neptune, they are also made up of gas, but they are so far away from the sun that they receive very little energy. So the temperature there is really very, very low. So even the gases are frozen. So that's the reason they are also called gaseous planet. And beyond these planets, there is a Kuiper belt where Of course, there's a Pluto, which is no more a planet. And there's a Kuiper belt object, small rocky things which are there. And it's believed that comets that we often see usually come from that region. And then there is an empty space, interstellar medium, until a 4.26 light years, where we encounter the first star. So I have shown here the planets' configurations. Now, these slides show you the current distance, brightness, and size of the planet as seen from Earth. So the average angular size in the sky for Jupiter is around 33 arcsecond. For Saturn, it is 15. See, Jupiter is the largest planet, so that's why it's seen as biggest and also significantly brighter as well. Then you have Mars, which is closer and has a angular size about 11.8 arcsecond, followed by Venus, Mercury, Uranus, and Neptune. The second row shows you the distance from the Earth as of today. So right now, Mars is nearest to the Earth, then Sun, then Mercury, Venus, Jupiter, Saturn, and so on. Now the position of these or the distance of these planets from the Earth will change depending on where they are in the orbit, right? So the Mars, Mercury, and Venus can swap their positions, right? Whereas the Jupiter, Saturn, Uranus, and Neptune, they would always be in the same order as far as the distance from the Earth is concerned. Now, as to the brightness, Venus is the brightest of all the planets. It's also called evening stars, followed by Jupiter, which has a magnitude of 1.97. Venus magnitude is minus 3.88. So the smaller the number, brighter the object, and that's how this scale is being decided. Mars, 0.56, minus 0.56, still comparatively quite bright. Then you have Saturn, which is 0.64, and then you have Uranus and Neptune, which cannot be seen with the naked eye. So you need at least small telescope to see Uranus and Neptune. Now, to understand the conjunction, how the planets align or at least appear from the Earth, they are aligned or they are going past each other, we need to understand how the planets move in the orbits, right? So few things we must keep in mind, and those are that when you look in the night sky, you would see that planets appear to change their position from one night to another or from one week to another, whereas stars don't change their position. We see the entire celestial sphere rotating, but that is because of the Earth's spin, right? Whereas the relative position between the stars do not change. That is, the one reason for that is because stars are so far away, almost like they are at infinite distance from Earth for all practical purposes compared to the planets. So planets' motion is easily seen as their position changes in the sky. The second thing is all the planets move around the sun in roughly the same plane. Okay, not exactly, but roughly. So the plane might change something like plus minus 3 degrees, with the exception of Mercury, which could be around 6 to 7 degrees. Another important thing is that all these planets move around the sun in the same direction, right? And the planets which are nearer to the sun, they go faster, and the planets which are farther away from sun, they go slow, right? So the nearest planet is fastest, the farthest planet is the slowest one. So that's how the gravity, the force of gravity works. And that's what decides the motion of these planets or the speed of these planets in the orbit. Now, the apparent motion of the planets that we see from Earth arises from these three things. One is their motion around the sun. The planets themselves are going in the orbits. The second is the rotation of the Earth about its axis. So Earth is also spinning. So it takes 24 hours for it to really complete one revolution around its axis. So that also kind of, when you're viewing it from Earth, you might see that position of this planet is changing because Earth is rotating. And the third thing is the motion of the Earth around the sun. So all these three factors would decide as how the planet would appear in the night sky. Now remember, since all these planets, including the moon, are uh, moving in the sky, and moon happens to be the fastest moving object in the sky among all the prominent objects, celestial objects in the solar system. And it changes its position. As you know, moon takes around 27.5 days to complete uh, one rotation around the Earth, which means it completes 360 degree divided by 27.5 gives you around a movement of 30 degree per day. So that's that's a lot of change in the position of the moon. So you could possibly see with the naked eye, you can feel it. If you stare at the moon, you would be able to make some sense of this movement. Now, before I go front, I just wanted to show you one movie so that about the. This is not a actual motion, but how the planet revolve. Just- Yeah, so this is the animation which is showing the motion of the planets in their respective orbits. So as I said, the planets that are closer to sun, they move faster. And as you go farther away from the sun, their speed reduces. So planets that are farther out move slowest. So once in a while, they come in a straight line and as seen from Earth, and that's what we call as conjunction. Now, this is a very idealistic simulations because in this, we are showing that all the planets are going exactly in the same plane, which is not the case. The planes of these planets are slightly tilted with respect to each other. So that's why we don't see the conjunctions or the transit or occultation happening very often. So, all right. I'm going to the slide once more. Uh, okay. And all right. Um, next slide. Moon is the fastest one. And 1 second. Just some trouble presentation. All right. That's fine. Now, what is conjunction? So planet move around the sun in different orbits. Closer planet move faster, and the farther out planet moves slower. Right? Now, a conjunction occurs when these two celestial objects appear to come closer to each other in the sky. So that's conjunction with respect to Earth, right? So if there are two other planets which are like crossing each other as seen from the Earth, then you can draw a straight line joining all these three, and that would be called as conjunction. So all the planets in our solar system can produce periodic conjunction because they are in orbit around the sun. And another thing about this conjunction is that about half of the time the conjunctions are happening at daytime and half of the time they would happen at nighttime. So we would miss half of the conjunctions that are happening. Now coming to the conjunction of Jupiter and Saturn, it happens every 20 years, and it's every 20 years, Earth, Jupiter, and Saturn, they just align in the solar system in a straight line, and that's what we call as great conjunction. Great conjunction because it involved two largest planets of the solar system. So that's the name, that's the why the name given as great conjunction. Now, to understand why it happens and every 20 years, we can try to understand it using a simple mathematics that is related to the orbital motion of these planets. So Earth is the inner planet um, compared to Jupiter and Saturn, and its distance is around 15 crore kilometers from the Sun, and it takes 1 year to complete one rotation around the Sun. Jupiter is 778.5 million kilometers. That's the average distance, which is like 77.8 crore kilometers from the Sun, and it takes around 11.86 years. So you can assume that it takes around 12 years for the Jupiter to complete one rotation around Sun. Saturn is farther out, and Saturn takes around 30 years to complete one rotation around the Sun. Now, what does this mean? Earth completing one rotation, 360-degree uh, cycle in 1 year, Jupiter taking 12 years, and Saturn taking 30 years. How does it transform to angular displacement in the sky? Right? So for Earth, it is fastest. So it's like 360 degree per year or 1 degree, roughly 1 degree per day, you can assume. And if you are observing Jupiter day-to-day motion, then you would notice that since it takes 12 years to complete one rotation around the Sun, every year 360 by 12, it would move by 30 degree in the sky. So that's not a too big movement over a period of 1 year. The Saturn further, it takes 30 years. So 360 divided by 30 is around 12 degree per year. So this, you can see, or you can, the Saturn stays in the sky for long. So there's not appreciable change in its position even from year to year. So that's because it's the farthest and the slowest, right? Now, so what happens is that you can imagine these Jupiter and Saturn and Earth to be like runners, which are in their respective tracks. Earth is going faster, Jupiter is slower, and Saturn is further slower, right? Now, if that is the case, then the faster runner is going to complete one laps and also going to catch up with the one which are slower. And same thing is happening with the Saturn and Jupiter. So Jupiter being faster, it is almost making a step of 30 degree per year in the sky, whereas Saturn is only taking 12 degree per year. So the Jupiter has a relative uh, position change in the sky with respect to Saturn is almost like 18 degree per year, 30 minus 12, right? So Jupiter is either closing the gap with Saturn with this rate, 18 degree per year, or it is receding away from the Saturn at this rate. So 360 divided by 18 degree, that is the relative speed of Jupiter with Saturn. 360 divided by 18 gives you 20 years time. So that is roughly how the math works out to be. That in every 20 years, Jupiter is going to go past the Saturn, and that's how we see these conjunctions every 20 years. Now, it is not exactly 20 years because Jupiter's orbital period is not exactly 12 years, it's 11.86. Similarly, for Saturn, it is not exactly 30 years, slightly less than that. So, instead of 20 years, we get conjunction happening every 19.8 years or so. But for all practical purposes, you can assume that it's 20 years period. So here what I have shown is, again, Jupiter, Saturn, and Earth, and Sun in the middle. So this would have been the position of these three planets in year 2018. Now we will make a jump to the, let us say, next year, 2019. So the Earth would have come back to the same position, but the Jupiter has just deflected by, as I said, 30 degree, whereas much less so the Saturn, which is only 12 degree. And then in December 2020, they are almost like lined up, and that's what is happening in this case. So let me show you the movie with, for 20 years run, how these planets would show up. So just, so this is little bit It's not a very smooth movement, but you can see that how the Jupiter is going to catch up with Saturn in every 20 years. So we started with year 2000 and ran this simulation over 20 years. And then Jupiter, so this was the situation in 2000, year 2000, when Jupiter and Saturn had aligned. And this was the situation in uh, year 2020, that is today. Okay, so that's what is causing the conjunction. I'm going back to the previous slide. Okay, so that's about how the conjunctions are repeated every 20 years, the great conjunction of Jupiter and Saturn. Now, here, what you see in the top panel is a plot which shows how the angular distance changes, angular distance between the Saturn and Jupiter changes with time, right? So I have plotted it between 1960 to 2020, right? And this sky blue curve is telling you how the separation, angular separation changes with time. And that has been repeating even for 1960. And if you go further from 2020, this pattern would keep repeating. So the top of these peaks are essentially where Jupiter and Saturn were separated by 180-degree apart. So they were literally on the opposite side of the Earth, just a case shown here, right? And these two positions, 90-degree positions, are here, where the angle between the Earth, Jupiter, and Saturn is 90 degree. And these are the bottom part where your plot is touching the almost like 0 degree apart. These are the position when the conjunction occurs. Now, this is not a smooth curve. That is because this is Earth's rotation around the sun. So Earth is also, it's going every year around the sun. So as you see these planets from Earth, from this moving platform, you would see that there is a small wiggle in their apparent positions. And this modulation is essentially the effect of that is caused by the motion of the Earth around the sun. Okay, so two things I want to the most recent great conjunction before today was in year 2000. But that time, the planets, Jupiter and Saturn, they were too close to Sun. Or we can say they were the opposite side in the orbit compared to Earth. So this 2000 conjunction did not happen at the night time. So it was not seen widely. Okay, even though a conjunction was there, but it was not visible because planets were too close to the sun. And that is 2020, that is today, the separation is going to be 1/10 of the degree. The separation between the Jupiter and Saturn is going to be 1/10 of the degree, which we will see what it means. And same thing would repeat after 40 years gap, 60 years gap, that is in 2080, right? So in a sense, that's why it is a lifetime opportunity. Now, what has been happening in 3 months? Now, these Jupiter and Saturn drawing closer to each other is not like it's not a one-day event. This has been happening gradually from last several weeks, and people were talking about it. This was in news, and today they are going to be the closest. So this picture shows you the position of the Saturn and Jupiter in the sky as it was in the month of October when they were separated by almost 7 degree apart. And gradually they became closer and closer. And at the start of this month, they were only probably 2 degree apart. And today is like 1/10 of the degree, or here the units are in arc minute, which is roughly around 6 arc minute. Now, how much is this 6 arc minute? And also, what is so special about today's conjunction? Now, for most conjunctions, the separation between Jupiter and Saturn is roughly of the order of 1 degree. Right? They don't really pass so close to each other. So 1 degree is a lot of distance, angular distance. Remember, a full moon is only 0.5 degree wide, right? So most of the conjunctions, Jupiter and Saturn is 1 degree apart. That means uh, their average distance would be roughly two full moon apart, right? So this line, vertical line, which I have shown to the right, is you can compare it to the moon, and it's basically the diameter of two moon, and that is the average distance, uh, angular distance between Jupiter and Saturn for most of the conjunctions. Uh, so today's conjunction is special because they have come so closer together, and that is 1/10 of the degree. So which is shown by this other small line, pink line, which is drawn against the thick pink line, which is drawn against this vertical longer line. Now, how much? Now, if you stretch your hand completely, and with one of your finger you would be able to block the full moon if it is a full moon. So you can imagine that uh, 1/5 of that distance is the separation between Jupiter and Saturn that's going to be for tonight's conjunction, right? Now this is a rare event because it happened 400 years before back, right? It's happening like first time, not first time, but the last time it happened was 400 years back in the year 1623. And 1623 was also the time when we had begun to understand about solar system. So Galileo had used the telescope to discover the four moons of uh, Jupiter, right, with a small 3-inch telescope. And he had also seen the ring of the Saturn. And mind you, from there and now, the 400 years time, there's lots of things that has happened. So it's good to put this in context as far as the astronomical events are concerned. So remember, at least to mention two great things that happened between these 400 years. One was that Neptune and Uranus were discovered. In 1623, they were not even known. So that time, only the 5 planets seen to the naked eyes were known. So another great thing that has happened in last 4 years is last 400 years is that people have the technology has advanced to such a level that uh, the probes were sent to these Saturn and Jupiter. So the first probe that visited Jupiter and Saturn was Pioneer 1, followed by Voyager 1 and Voyager 2 in late 70s and 80s. And then there was also Cassini as well as Juno. So there were 4 probes which has visited these planets, outer planets, and even gone beyond. So that's a lot of progress in 400 years. Now, another interesting thing about that 1623 conjunction was that it happened at daytime, right? So you may have heard that this is a unique event in 400 years. Some people are saying it's unique in 800 years. So it is unique in 400 years because this Saturn and Jupiter came so close in 400 years back, but that happened during the daytime. So probably nobody noticed it because it's not possible to see even the brighter planet during the daytime. So that is like, so there's not even a record of it which exists. If there was such a conjunction, we would have found a written record, but there's no such thing. So probably nobody had seen that conjunction. But the conjunction that was seen up so close before that was 800 years, and that was in 1226, right? So in that sense, yes, we are seeing, or humanity is seeing Saturn and Jupiter coming so close in the sky after 800 years. That's true. So next conjunction with this much separation would take place in the year 2080. And another special thing about today's conjunction is that it also happened to be on the day of winter solstice. Today is the day of winter solstice for the northern hemisphere. So, what is winter solstice? It's winter solstice is, Earth is spinning as well as going around the sun, and it has axis. The axis is tilted by 23 degree, and so on. So, different part of the Earth or different parts of hemispheres are receive light from the sun in different manners. In winter, it's the tilt is uh, the Earth is tilted most in the northern hemisphere, so it receives less light. And uh, on December 21st, sun arrives at the southernmost point on ecliptic. So ecliptic is a apparent path that sun takes in the sky. It's basically Earth going around the sun, but to us it might appear that sun is going up, and that path is called ecliptic. So there's a ecliptic, and then there's a equatorial plane, and they are aligned at 23 degree, right? And on 21st December, the sun is on the lowest point on in the southern or in the northern, from seen from the northern hemisphere. So this is also happened to be the shortest day on the northern hemisphere. And another way to put it is that if you measure the shadow of any object on this day, it is going to be the longest shadow on any day of the year, right? That's because sun is far in the south. So occurrence of this conjunction on the solstice day is just a coincidence. There is no other significance out of that. It's just that these two days happen to fall on same time. Now, how to view the today's conjunction? So, if you are like watching this talk and if you're interested to uh, really go and see what's happening outside, and you want to take a look at the Jupiter and Saturn, so first thing you do is just choose a right place. Either go to the open field where there's nothing to obstruct your view, or go to the top of a building. So from there, you should be able to get a clear view of the western horizon, western sky. Now, immediately after the sunset, when you look southwest, you would be able to clearly see Saturn and Jupiter. Now, they are so bright that you simply cannot miss them, right? Uh, so, they are so bright that you wouldn't be able to miss them. And uh, immediately after the sunset, uh, you well, there is also going to be a lot of stray light, twilight, and the best time to view the Jupiter and Saturn would be like around 7 o'clock, because that's when they would just come closest, and also it will be dark enough to see them. Now, how would you see them with, yeah, they will be seen with the naked eye, and they can be seen from any place on the earth, except maybe the uh, southern pole, because it's all daytime there. Uh, but from otherwise, they are seen from any place on the earth. The It may vary, the elevation may vary depending on where you are, and also from the city lights. So the good thing is that, unlike if you are a stargazer, you need clear nights and clean cloud-free nights. But in this case, when you're looking at planet, they're so bright that even from city like Bangalore or Delhi would be able to view the planets. Now, whether you see them separate or close would depend on the local sky conditions. Uh, so yes, if you have a good eyesight and the sky conditions are good, you would still be able to see them separate, barely separate. And if your eyesight is not that great, then you would see them as just like a very bright star, though they are not stars, they're just but bright objects in the sky. And in addition to that, you would also be able to see the crescent moon. Okay, crescent moon. So moon is going to be further south and little bit up in the sky. So it's really a great treat to have these objects together in the today's evening sky. And also, if you want to photograph them, you should be able to use your smartphone or SLR camera to kind of take the photograph with these planets. Uh, Now you can use your cameras in the night mode when around 7 to take the photos. All smartphones have that feature. Now, these planets, another interesting things about today's event of this kind is that if you have a small telescope, you can see Jupiter and Saturn together through a telescope, right? That's not usually the case because the separation between them is most of the time is more than 1 degree, and things that are 1 degree apart, because telescope has a high magnification, so they cannot be seen in one field together, right? So it's only this occasion of this kind when they are really very close, 0.1 degree apart, that you can see them together. And only you have to make sure that uh, you put your telescope on a flat, stable platform. And if you're using binocular, then again, you would be able to see them nicely. But again, to have a steady hand, you need to take some support so that things don't shake up. So this is one of the image that I have shown here. So if you're using a small telescope, you would also see the 4 Galilean moon that Galileo has discovered, namely the Callisto, Io, Ganymede, and Europa, in addition to Saturn and its moon. So this is the picture that was taken on 19th December from Leh by our colleague Durjanchuk. And it shows that, yes, it was taken with a 12-inch telescope with a Canon camera behind it. So you have Saturn, which is seen here, so, and also Jupiter, which is bright, and 4 moons of the Jupiters, which are again marked here. Uh, this picture was taken day before yesterday, and this was taken last night, just after sunset. So you can see that the position of Io has changed. It's really very close to Jupiter, and tonight probably it will be just in front of the Jupiter's disk. So that's again, this image credit goes to Anshul Durche from Leh. Now, this was the image again taken from our field station in Leh, and again by friend Durjanchuk. And if you have visited Leh, you may not have missed this Santi Stup, which is there, which is a prominent building in Leh. And this is what is showing Jupiter and Saturn as well as the moon captured with the camera. So this is not taken with telescope, this is taken directly with the camera, and it has come out really beautiful, remarkable image. Now, in addition to conjunctions, there are also transits and occultations. So what is conjunction and what is, how conjunction is different from transit and occultation? Now, if Jupiter completely covers Saturn, we would call it as occultation. It just completely blocks. So when one object blocks the another object, that is called occultation. So what are the other example of occultation? Total solar eclipse. So when there's a moon which comes in front of the sun, their disk size is roughly same as seen from Earth, there is going to be a total solar eclipse. So its sun is occulted. So there Jupiter can also, in very rare cases, Jupiter can also occult Saturn. We'll see that how often that happens. And the transit is not completely occulting the disk of the Saturn or any other planet in the background, but partially occulting it. So that's called transit. And transit is well known in case of, you must have remembered the transit of Venus and Mercury, where these planets are seen scrolling across the disk of the sun, right? Now, in case of Jupiter and Saturn, the occultation, the transit and the occultations are really very, very rare. So in the next 10,000 years, Jupiter will transit or occult only 3 times. It's going to, so transit Saturn or occult Saturn only 3 times. So that's going to happen in, the transit is going to happen in years um, 7541 AD, February, and the occultation in the same year on June 17th. So today, so that is like how many? More than 5,000 years away from today. And the transit will again happen on February 25th on 8674 AD. So these are really like several thousand years apart, and we don't even know what would be the face of Earth then. Now, you may ask, why don't we observe these transit and occultation very often? And the reason is, as I told earlier, that the orbital plane of these planets are not in single plane. Orbits of these planets are not in single. There is a relative tilt between all of between these, and because of that, you don't always see transit or occultation happening. If all these planets were orbiting in the same plane, exactly in the same plane, then you would have observed these occultation much more frequently or transits much more frequently, but that's not the case. So this is same thing like why we don't see solar eclipse every month, because moon apparently comes between the sun and earth, right? But not exactly, because there is a tilt in the orbit of the moon and orbit of the earth. So most of the time it misses. It's only in very rare occasions that they are aligned perfectly and total solar eclipse is observed. So same thing goes for the occultation or transit of the Jupiter and Saturn. So the conjunctions that you can watch out for future are listed here. So today is the great conjunction Jupiter and Saturn. So what is listed here is also the separation between those. So 13th July 2021, you will see Venus and Mars occulting, a conjunction of Venus and Mars with 0.5 degree separation. On 5th April 2022, Mars is going to, it's going to be Mars, the conjunction of Mars and Saturn with a separation of 0.3 degree. And then you will have Venus and Jupiter conjunction that's happening on April 2022 with a separation of 0.2 degree. And in May 2022, you will have Mars and Jupiter again showing up around 0.6 degree apart. Now, the inner planets like Mars, Venus, and also with respect to Earth, the occultation is more frequent because they go faster. So it's very likely that you would catch up with other planets and they would be aligned appropriately to be seen as causing a conjunction. So what are the takeaway message from this? That we all know that these conjunctions, occultations, transits, or eclipses, they are all natural phenomena that happen because of the reasons that we just now discussed. And we shouldn't be afraid of these things that are happening in the sky. And there are also lots of rumors and the fake news that are spread about these conjunctions. So you really don't have to worry about those. Believe me that there's nothing, they don't cause any harm to human life. So you just need to go out, step out, and just enjoy these celestial events because they are truly, truly like once in lifetime opportunities. As I said, same thing happened 400 years back, but even then it was not seen. So only 800 years back, people were able to see. And so it's nice that this generation is like happen to fall in this time, and we will be able to at least witness this event. And that's the only significance that this event has. But only these are the celestial events. So a great show which is happening in the sky. So that should be much more inspiring and exciting to watch. So that was my last slide for today's talk. So if you have any questions, you can post it in the YouTube comment, and my colleague would probably read those out and we can answer those. Another thing I want to probably share with you is that we also have arranged a live streaming of the conjunction, great conjunctions, and the feed is coming from our feed station in Leh. So this would start around 6 p.m., not too far from now. And you can use this link, which right now you are seeing on your screen, to see the live streaming of this great conjunction event. And I would, so Swastik, is there any question from audience?
Hi Ravi, yeah, so we have few questions in the chat box. So Tushar wants to know that if this event will be visible from other parts of the world, such as Europe and other continents.
Yeah, so the great thing about this event is that it would be seen from almost all the parts of the Earth, right? Except, as I said, in the southern pole where it's daytime, 6 months day, 6 months night. So this time happened to be the daytime. So daytime, you don't really see the planet, even though the planets will be visible in the sky. But except that, it would be seen from all the places. And hopefully, if it is not cloudy, everyone will be able to view it.
Okay.
And it's also like you don't need telescope to see this event, because planets are bright enough to be seen with naked eye. Yes.
We have another question from Srikar. So he wants to know if this conjunction has any historical significance, like there are saying that Christmas starts from conjunction, and also any comment on that line?
Yeah, so see, the Christmas star is like it's basically a story in the Bible when Jesus was born, and three wise men from east came to see him, thinking that Jesus is God or some great person that has been born. And the myth goes that these three wise men were guided by a bright star in the sky, right? Now, and so you may have heard lots of news about this conjunction is basically probably the repetition of this bright star that was seen then, right? But there's probably no evidence. First of all, the birth of Christ is not 0 AD as it is being put. The most scholars date it back to 5th or 6th AD, I think. And what it was then, what was referred to as the Christmas star, it's not very clear what those people really saw. So there are speculations about it. So yes, it could have been a conjunction of this kind. But then the story also says that once these wise men have reached Bethlehem, that's where Jesus was born, then the star disappeared. Now, star cannot just, or the planet cannot just disappear. Even for today or tomorrow, you will see that they would still be seen for several days. So that's one explanation, that yes, it could have been conjunction, but that's just a guesswork. We don't know. There's no way to authenticate it. And the second is that, that bright star, there was no bright star, but maybe there was some planet that, the comet that people may have seen in the sky, and that's what is now called as Christmas star. But other than that, I don't know much. I mean, it's just a story, nice story, and that's part of most cultures. They look at heavenly objects and try to integrate it with their own folklores, on stories, on their own cultural beliefs, and so on. Yes, so that much for the Christmas star.
Okay. So Sam wants to know, like, as you have mentioned that there are no proofs to what happened around 1600s. He wants to know how we predict that this will reoccur in every 400 or 800 years for this
Oh,
event.
now see, the planetary motion is now very well understood, right? Once you know the Kepler's three law, you can predict them until something else disrupt the solar system. This would the prediction. You can predict things like for several tens of thousands of years the planetary motion with a very high precision. So that's not a problem. That started with the Kepler, and now because of your good computing facilities like computers, you can easily predict what had happened before and what would happen in future, right?
Okay. So
So the law of planetary motions are very well coded in the sense that they are well understood, right? Even the small minute variations that are there, they are taken into account, and one would know the trajectory of these planets not for today, tomorrow, or even 100 years from now or 10,000 years from now. Yeah. What was the other question?
yeah. So Priya wants to know, like, if since Jupiter and Saturn are in the straight line, so what is the approximate distance between them? And like, I feel the question is
Yeah.
like, is it the closest between Jupiter and Saturn at this point, or can we make any comments whether these two
Yeah.
planets are the closest or not?
Right. So even though we say they are coming closer together in the sky, physical distance between them is still very large. So it's going to be around 600 million kilometer. Saturn will be separated from Jupiter by 60 crore kilometer. That's a huge distance. So physically they are still far apart, right? But it's just that their viewing geometry with respect to Earth, they appear to be aligned with each other. So remember, Jupiter is closer to Earth than Saturn is to Jupiter, right? So the distance between Earth and Jupiter is less than the distance between Jupiter and Saturn. Okay. So yes, the physical distance would not change much. Yeah, it wouldn't be minimum either, right? Because it could be minimum, but then Earth will not be aligned. So that possibility also exists. So this is not the case where Jupiter and Saturn's are also physically at the closest distance. No.
Okay. Sampada wants to know if scientists are interested in any particular experiments during such conjunctions. So, do we get any scientific important results during such times?
Uh, yeah, conjunctions are important, transit conjunctions. I don't think they are so important scientifically now, but early on, I think conjunctions and transit play a very important role, especially establishing the distance between the Earth and Sun using the transit of uh, Venus or Mercury, one of those. So there were like expedition planned in order to kind of. So once you know that geometry correctly, and also compute the timing of crossing from one side to another, you would be able to like get the distance at least from the Earth to some of these objects. So as I said, the first time the distance between Earth and Sun was measured with the transit of uh, Mercury, I guess, Venus or Mercury, but one of those. Uh, so yeah, but now it's just like it's more, or there are better ways now to at least determine the distances, but the fascination still remains. I mean, it's still a great thing to view these planets. One can do small experiments and try out like a few things, and just to get some idea about how much time it takes for transiting or for occultations and so on. And if you know a little bit of math, you would be able to compute some more orbital parameters, but they are all known now. So there's nothing like you will find something new.
Okay. So maybe you said this.
Yes, maybe I can add that
Yeah.
just like we have transit of planet here, the transit method is a very famous method which is now used to detect planets around other stars, right? Just we have planets in solar system. There are planets around other stars, and there are several techniques that are in place to detect the planets around other stars, which we call exoplanet or extrasolar planet. So transit method is one such method where a planet goes in front of the star and you basically see the dimming of the light of the star because planet is blocking some of the light as long as it is in front of the disk. And that by measuring that dip in the intensity of the star, you can infer that there is a planet around other stars. So yes, scientifically the transit, by observing the transit around other stars, we get to know more about planets around other stars and their sizes, and also about their other orbital parameters. So in that sense, yes, uh, the transit has relevance to this very hot field in astronomy astrophysics, which we call as exoplanets. Yes, Swastik?
Yeah, so we have a few more questions. So in your talk, you showed that there was an angle plot. So Priya
Yes.
wants to know, how do you precisely measure the angles between the planets? Like you showed 90-degree and 60-degree. So how do you measure the angles between the planets in general?
Oh, how do you measure angle between the planet? I
Yes.
see. So for all the configurations, you don't really need to measure angle. Once you know at least the other parameters of the planets, like Jupiter's orbital distance, its speed. Once you know the speed, you will be able to find out the orbital distance, and vice versa using Kepler's third law. And you know the inclination of these planets, then it's easy to predict what would be the separation between two planets or between any other planets, be it Earth, Mars, or Earth, Jupiter, Jupiter, Saturn, and so on, which can be calculated easily, right? But if it is in the sky, yes, as long as you can, let us say, see the objects in the sky, measuring their angular separation from Earth is not difficult, right? You just need a device which can, let us say, uh, point out to each of these. Earlier time, the angle used to be measured that way, right? So you just first point your device to one of the planet of interest, and then see how much you have to move that device to get to the another planet. That would give you a rough angle. Okay, but that is just a projection effect that you are measuring from Earth. That may not be the real angular separation. But real angular separation you can calculate once you know the other parameter, as I said.
Okay, so you discussed it in the talk, but still Akhil has some confusion on this. So if half of the great conjunctions are happening during night time, why are we not able to see most of them? So that's
No,
his question.
yeah, so I was saying this in the context of Jupiter and Saturn conjunctions. So Jupiter and Saturn conjunctions are happening every 20 years, right? But since it's like why there should be a preference for day or night. So conjunctions are equally likely to occur at daytime as well as at nighttime. So the statement that half of them are happening at daytime and half at night holds true. So we did not see the conjunction 2000, the conjunction that was there, the great conjunction of year 2000, because it happened close to daytime, right? Whereas we are able to see it now. So uh, yeah, you see half of them. Statistically, if you have a sufficiently large number, let us say 1,000 events, then 500 would have fallen in daytime, 500 would have fallen at nighttime. But you can't say that last one was seen during daytime, this one has to be at night. So there's no pattern as such. But statistically, they are like occurs, half of them would occur at daytime, half of them would occur at nighttime. So the one which occur at nighttime, we see them. right? The conjunction of, let us say, uh, other planets is much more common because they are going faster, like Venus or Mars, if you want to check them. That would be much more frequent because they have a shorter orbit and faster speed. Now, so it doesn't really become a great interest if the when conjunction is happening, the separation is large. If it is more than 1 degree, probably nobody even pay attention because that's not something very spectacular thing to be noted. So they happen, but probably it's just that it's not a hot news. Just it happens to be the case for this event. Right? I don't know if I have clarified that or not. Anyway, any other questions, Swastik?
So we have our last question for this session today. So Sam wants to know, he's just curious whether if it's ever possible that all the planets will ever align in the same line. So if the scientists have calculated when this event might occur in future, when all the planets
Yeah,
will be.
I think theoretically that possibility cannot be ruled out. The question is that when it will happen. I'm sure the calculation may not be impossible to do, right? But aligning in one line, yeah, I thought it probably happened not too long back. So the question is whether they would be, see, the all aligning in one line can also happen, half on one side of the sun, half on another side of the sun, right? That would also be alignment. But having all of them aligned only, let us say daytime or nighttime with respect to Earth, uh, that probability will be further lower, right? But I have not looked into this, whether uh, such a thing is predicted. And if at all it is there, it's going to be extremely rare that all of them lined up together. Yeah, but it cannot it we cannot rule that out.
Okay, Ravi, so just one more question just popped up in the chat. So I'll just end up the session with this. So does this conjecture has any gravitational effect or any other effect on Earth in particular? Any comment
No
on this?
conjunctions, so nothing, no effect, because as I said, even though Saturn and Jupiter are going to be seen very close in the sky, but their physical distance, their actual distance between them is still like around 60 crore kilometer. So that is not going to have any other additional effect other than what we already have, right? So it's not going to perturb anything. Jupiter is not going to perturb Saturn. Saturn is not going to perturb Jupiter, right? So no, there wouldn't be any such effect because of this conjunction.
All right, then we have taken almost all the questions that were there in the chat box. So with this,
Yeah.
yeah.
So I would again urge people to just step out and see if you can see today's conjunction. And even if it is cloudy today, you can still go tomorrow or day after because this is going to last for some more days. I mean, the separation between Jupiter and Saturn is going to increase, but it would still be a nice sight to watch because from today onward, Jupiter would just start departing away from Saturn in terms of the distance or in terms of their separation as seen from the Earth. So please go out, and we would also have this live streaming of this event from our field station at Leh. So you can also join using the YouTube link that is given here at 6 o'clock, which is not too far from now. It's close. So thank you once again for uh, joining, and we would have many more talks in outreach in the days to come. Thank you.